I'll open up the chat over here so I can see if you guys have anything to say. You can chat it over here. And I think I'm ready to go. So, all right. Okay. So I probably won't like do all of this or whatever, but I'm going to talk about it just because I had a few people ask me about it and asked me to talk about it today. So the extra credit assignment this week is probability. It's practice with probability. And really the goal, when I look at it, the goal is basically to have you do an actual procedure / experiment and compare it with the theoretical probability that you will have. So you could see my screen, right? You've seen this document. This is the document for, yes, Frankie, I have my coffee. You know this. I always have my coffee. That's my go-to. All right. I have a new latte machine. So the addiction is real. All right. Anyway. So all right. So yeah, so you've seen this. This is the document for your probability extra credit this week. So the student will use theoretical and empirical methods to estimate probabilities. The student will appraise the differences between the two. And that's the thing, the idea is to look at the difference between the two. You might see some differences and then, analyze why. The student will demonstrate an understanding of long-term relative frequencies. And that's the idea of when you calculate, when you calculate your probabilities, you're calculating your probability based on the fact that the experiment is run over and over and over and over and over again, and it will approach your calculated value. But this, is a quick little thing. Count 40 mixed color M&Ms, which is approximately 1 small bag's worth. Yum, you get to eat them after. Choose these M&Ms randomly. Record the number. So yeah, so you have a bag of M&Ms and then you just want to count how many yellow, green, blue, and that's what you're putting here. How many of each color you have in that bag. That's easy. The experiment is to pick 2 M&Ms one at a time. So you're always talking about selecting 2. So for your first, see experimental portion, this is where you're actually doing the action. Do not look at the items as you pick them. You will do 2 methods. So you're going to do 2 different situations. You're going to do one with replacement and one without, each 24 times. So, I know. With replacement, you're going to go to this bag of M&Ms and you're going to look away and you're going to pick 1 M&M. Look at the color, right? Remember the color, document it, whatever, and then put it back and then pick another one and look at the color. And I think the first table here, yeah, you're basically gonna count how many, situations you've had. So you might want to write it down as you do it, like with replacement, do it first and then put the values in here, because otherwise it might take longer to find it and do it the other way. I'd probably go to the bag and pick one, look at it, pick the other, look at it. And then if it's for example, a yellow and a yellow, I'll put Y and Y for my first one. And then for my second one, I'll have maybe a little paper on the side to write my outcomes, you know what I'm saying? And then I'll go in here and I'll go, okay, I had a yellow and a yellow back to back when I did with replacement twice. So this is 2, you know what I'm saying? That's kind of how this table is done. So you're not going to basically have numbers for all of these situations. You might not have all of these outcomes. These are all the possible outcomes, at least they should be. And then you have your with replacement and your without replacement column. So that's that part. And you guys know the difference between with and without. Yeah, you wrote yours down. Yeah, that's what I would do. I'd write it down and then go back and input into that table, because it might be longer if you don't do it that way. And then, with replacement, you look at it, put it back, pick the next one, put it back. Without replacement, you pick up the first one, you keep it next to you, and then you pick the second one, and then you record that. But now here, these are the theoretical probabilities. Use the data from table 1 to calculate the theoretical probabilities in table 3. Write your answers in simplified fractions. So this is table 1. No, this is Table 1. Oh, okay. So I might make something up here. Let's assume, I'm going to show you something because this is going to help you with overall probability anyway. So let's assume that I go and I'm going to make it up, like 6 yellow M&Ms. What other colors? I don't know. 5 green M&Ms. I like blue. Let's go 8 blue. I don't know what's realistic. 8 brown. I haven't had M&Ms in a very long time. What do I have? 16, 22. I'm missing some. Orange and red. Orange and red. So I'm gonna have to figure out. Let's do another 8. What's left? 8 times 3 is 24, and 11 is 35. So 40 to make 40, right? All right, I have to have a total of 40. Let's just double check. 6, 5, and 8. Double check. 6, 5, 8, 8, 8, 4. Okay. So I want to have a total of 40. And that should be, oh, I missed one. We'll make this 5. Okay. So let's assume this is what I have. 6, 5, 8, 8, 8. Okay, good. Just making sure. So I should have a total of 40. And then you're going to calculate these outcomes, right? And I'll show you how to do some of them. This is like basically what we're doing with our calculations. Calculate these probabilities. So assume, you're not actually doing the experiment with this. You're just calculating this type of situation, theoretical probability. This is your empirical probability. Use the data from table 2 to calculate the empirical probabilities in table 4. Write your answers in simplified fractions or decimals rounded to 4 places. I probably would want I said 5 and wrote down 4. Go figure. That's stuff I do. So like how you would do this, I'm going to show you this first. How you would do this is if you have a red and a red, right? And you're doing your empirical probabilities, you're going back to this table to do the empirical probabilities, and you have a total of 6, 1, 2, 3, 4, 5, 6. Yeah, you have 36 total outcomes. That's what this shows. 36 total possible outcomes. And if you are doing your calculation empirically here, the probability that you get a red and a red, you're not doing it based on what you've done like in your assignments. You're doing it based on what you got when you actually went and did this experiment. So I would go to this table, and let's just talk about red and red for now. And I would go, how many red and reds did I get with replacement? Like, let's just start with replacement. And let's assume that I had 2 here, right? Assume I had 2 outcomes that were red and red. So then my probability here, my empirical probability with replacement would be 2 out of the total 36. And then I'd probably approximate that. I don't know why this is so light where you can't see it. Is that better? Okay, that's better. Does that make sense? And then whatever that decimal is. Let's go red, brown, or brown, red. This is empirically, right? Red, brown, or brown, red. I know my total outcome is 36. It's going to be out of 36, right? This is just how it downloads. For some reason, it just, okay. So let's look for the red, brown, or brown, red situations. So here's a red, brown with replacement. Let's assume I had one of those. Or brown, red. Here's a brown, red. Let's assume I had 0 of those. So in total, because the OR case I would add, let's say I have 0 plus 1. I had 1 out of 36 total of the red, brown, or brown. So this is me calculating the probability empirically based on what I got here. Okay, it's always going to be out of your 36 because there's 36 total outcomes. And then, it's just what you get here. So the OR case you're adding, Red, then green, that's telling you one particular situation. Red, then green, that's here. That's the only one I have of that. Red, then green. Let's assume, even if you have 0 here, if you got 0 outcomes that were red, then green, you would have 0 out of 36 as your probability with replacement. You'd do the same thing with the without replacement portion, right? Green second, given red first. Green second, given red first. That would be red, then green again, right? What'd I say? I had 0 of those. That's the same thing. So 0 out of 36. Okay, and then no yellows. When I'm looking at no yellows, that's all these situations that happen. So none of these all have yellows. This one has yellow. So I would be considering 1, 2, 3, 4, 5, these 5 scenarios plus these 5 scenarios plus these 5 scenarios plus, right? All the ones that have absolutely no yellows. You'd have to add up all those outcomes and then out of 36. This is me doing it again, empirically, whatever the heck that outcome was, okay? And then doubles, both same colors, you red, red, whatever that is. Let's say I had 2 there, orange, orange. Let's say I had 0 there. Brown, brown, 1, blue, blue, 3. I know you can't see these very well, but green, green, 1. You're just adding up all those outcomes that had the same color twice. And then that total amount, let's assume I had 4 out of your 36 again, because it's technically addition. You're doing the OR case, right? You're doing the OR case. So, you know, you can get a red and a red, or you can get a green and a green, or you can get a brown and a brown, or. So you got to add up all those situations, okay? That's this empirical probability, right? So I hope that makes sense. Tell me if that makes sense. That's the, you know, procedure part that you have to, you know, physically do. This is the part that we're like practicing how to calculate. Questions on the empirical part, or does that make sense? You could type it too if you have a question. Okay.
So this is recording, right? Because I missed, this is recording, right?
Yeah.
I have missed some beginning, like 15 minutes.
Oh, yeah, yeah. Yes, I'm recording it.
Okay, thank you. Appreciate it.
Okay, so when we're going to the now theoretical probabilities, this is kind of like you're on your homework. This is now, you know, if you were to repeat the experiment, so, you know, multiple times over and over and over and over again, what would you approach? What probability would you approach? So I'm going to do some of these, and actually red, then red. So this is the good practice. This is what we need to be able to do, you know, like for assignments. You know what I'm saying? Because you're not physically doing these procedures when you're doing these homework assignments. So we're going to practice this. So, you know, with and without replacement, with and without. You guys are going to help me with this. Remember that I'm always selecting 2. And for you guys that, you know, were here yesterday or, you know, listen to my stuff, when I say we select more than 1, which rule are we always using? Always using a specific rule when we are selecting more than 1.
Multiplication.
Multiplication rule. So since I'm selecting 2, I'm going to multiply twice. This will be my with replacement, and this will be my without. Okay, they're separate. And I'll probably approximate it also. I'll probably do it in fraction and decimal form. So what is the probability? I go to this bag of M&Ms, and I want to eat a red and then a red. Although I can't eat that because I'm replacing it. So I'm not eating it. I don't like red. So we're going to go, what's the probability I select a red, go ew, put it back, and then select another red. So on my first selection, if I have a total of 40 M&Ms and I have 5 red, what's the probability the first is red?
5 over 40.
5 over 40. Now, being that I'm replacing it, I'm not affecting the number of reds. I'm not affecting the number of M&Ms. So the second red would be a probability of
5/39.
5 out of 40 still. Only reason not 39 is because I'm putting it back. This one is with replacement.
Oh, yes.
And this one's going to be without. So, all right, let's look at the difference between the two. Without replacement, the first selection is going to be the same. It's the second selection that's going to change because I'm not replacing the red. I'm going to eat it this time without replacement. So now, how many reds are left in my bag?
That would be 5/39.
It would be over 39 because I only have 39 M&Ms left. But I did eat a red, and I want another red. One of the reds is gone. I have only 4 left. This is when, you know, it decreases in the numerator like it decreases in the denominator because it's the same color twice. So technically, if I'm eating a red and I'm not putting it back, I have 1 less red. If I were looking at red and then green, that might be actually, I'm gonna make some stuff up too. Maybe I'll red and green. Let's do that. Red, then green. Let's do that. I don't like when I'm sloppy. Okay, red, then green. Okay, let's do that. What's the difference between red and red versus red, then, you know, another color? And then you can approximate it if you want, because it says you could do it a simplified fraction or an approximated decimal. And I'll show you on one of them how you can get the simplified fraction on the TI-84, but if you want to do approximated decimal, you can do that too. All right, cool. So with replacement, I go to this bag and I pick a red and then a green. So let's start with the red. We already know picking a red is 5 out of 40, but if I put the red back, what's the probability I get a green on the second grab? Because I put the red back.
Is it 5 out of 39?
5/40.
Or sorry, I was looking at the other side.
Well, yeah, 5 out of 40 again, only because I also have 5 green as I do red. So you know what I'm going to do. I'm going to color coordinate just so, right? You realize it's not the same number because it's the same thing. It's the same number because I actually, in this particular scenario, have the same number of green as I do red. That just was coincidental. You might not have that situation based on your bag of M&Ms. Okay, let's go to without replacement. For my first selection, without replacement, I want red. So we already know 5 out of 40. We talked about that. But now, now my second selection, I want to be green, and I ate the red. So what's the probability that on my second selection, I get a green if I ate the red first?
It would be 5 out of 39.
Yes. Make sure this is green. 5 green still, because I didn't eat any green. I ate a red, but 39 total because I ate one of the total 40. So you see the difference between this one and this one. You know, if I eat a red and then I want another red, right? I decrease the number of red and I decrease the number of total M&Ms. But if I want a red and then a green, I ate a red, but that didn't affect the number of greens, but it did affect the number of total M&Ms. Okay, so you see the difference between the two, right? Okay, let's do red, brown, or brown, red. Probability, oops, that's not a P. Let's go back to my blue. Probability of, we're gonna go red, then brown, or brown, and then red. Okay. Automatically, let me use pink. Pink is nice and bright. Automatically, I see or, and so I know I'm going to add stuff. So let's add. Something's going to be added. And I'm color coordinating here. My first situation here, because remember, the or situation implies addition, right? And I actually should have asked you that rather than telling you that because you should know that, right? But this is a combination, this type of problem is a combination of the multiplication rule and the addition rule. Because I have the or case, I want to talk about this situation or that situation, so I have to add the total probabilities to be able to get the total probability for the situation. But when I talk about this one over here, this is a red and then a brown, I'm selecting 2 just in that scenario over here. which implies multiplication. And then over here, I'm selecting 2 again, and that implies multiplication. And I still want to add the 2 scenarios together. So I have a combination of the multiplication rule and the addition rule here. So we'll call this like situation 1, just to kind of organize it. And then I'll use black. Situation 2, okay? So let's talk about situation 1, where I have 2 I'm selecting, right? So that means multiplication rule, and I'm multiplying 2 scenarios. But I want the scenario or the situation where I get a red and then a brown with replacement. We already know, obviously we like selecting red, man. I might have to change that to blue because I like blue better. But anyway, I have 5 red out of 40 total, right? But then I want a brown after the red. So if I want a brown after the red, what's the probability that I get a brown, given I already had a red, but I replaced the red? What's that second fraction that goes here?
8 over 40.
Mm-hmm. And she chose 8 because of the fact that there are 8 brown. 8 out of 40. I didn't decrease the denominator because I'm replacing it. I didn't eat it, right? But that's the first situation where I go and I get a red and a brown. Or, well, let's add this other situation as our total. Or this situation here, where I get a brown and then a red. So she already told me the probability of a brown was 8 out of 40 because there's 8 brown out of 40 total. But if I pick the brown first, what's the probability of getting a red second if I replace the brown?
It would still be 5 out of 40 because it's 2 different scenarios or situations.
It would still be 5 out of 40 because I still have 5, what do you call them? 5 M&Ms in the bag. It would still be out of 40 because I replaced the first. But you see how it's a combination of the multiplication rule for the 2 situations, because I'm selecting 2 in those 2 situations. But I'm talking about this or that. So when I do the or situation, now I have to replace or with my plus because or implies addition. I add the 2 situations together to get my total probability. Now this one I'll show on my calculator because you have like a lot going on. I'm going to show you how to do it. And then I'm going to show you how to get the simplified fraction if you want. So I have 5 out of 40 and 8 out of 40. 5 out of 40 times 8 out of 40 plus, and you could do it this way because according to the order of operations, it will do the multiplication before it does the addition. Out of 45 out of 40. Now, you could also, if you notice, it's the same thing twice. You could just raise it to the second power, do the calculation, do like 5 out of 40 times 8 out of 40, and then raise that whole thing to the second power if you want it that way also. 0.05, if I want to convert that into a simplified fraction, the TI-84 does stuff like that for me, so I can go math. And then number 1 is like arrow frac, and press enter. So it's going to take the last answer, it's going to convert it to a fraction, and it simplifies it for me 1 out of 20. So the simplified fraction here is 1 out of 20. If I want it in decimal form, it's exactly 0.05, which is highly unlikely, 5% chance of that happening, which I would imagine. And you'll probably compare that. You want to think about comparing that to, what you would get here. Did you get something similar here as you did here? Are they different? Are they close? Are they very different? Et cetera, et cetera. You know what I'm saying? Because you'll probably be asked something about that in the discussion questions, which you want to be nice and clear and thorough with, right? But this one was with replacement. What's going to change if I do without replacement? So I have to do the same thing because I want this or that. I'm going to add these 2 situations together. But when I talk about the first situation, I'm selecting 2. So I have to multiply because whenever I select more than 1, I have the multiplication rule. I want red and then brown. And then over here, again, I'm selecting 2, multiplication rule, brown and then red. But this time without replacement, so I have dependent events in these 2 situations. Whatever, not a big deal. Let's talk about the first one where I select a red and then a brown. Again, we already know about the red, 5 out of 40, right? But if I eat the red, because I'm not replacing it, what's the probability I get brown on that second pick?
8 out
8
of
over 49.
39.
Yeah, 8 out of 39. I still have 8 brown. I didn't eat the brown. I will eat it after that. But 8 out of 39, 39 because I ate the red. I have 1 less total M&M in there, right? This is just this situation. Plus this other situation that could potentially happen separate from this one. Getting a brown and then a red. All right, well, you guys already told me about brown. I got a brown first. Go ahead. You could tell me. 8 out of 40. Then what's the red after the brown?
5 over
5 out
39.
of 39.
You guys are completely correct. 5 out of 39. And yeah, I still have the same number of reds, but not the same amount of M&Ms. Wait, so 5 out of 40. Let me do this. So we got 5 out of 40. We'll do this one. And then 8 out of 40 off the top of my head. Plus, oh, sorry, 8 out of 39. Whoops, don't make that mistake. 8 out of 40 and 5 out of 39. 8 out of 40, and then 5 out of 39. Okay. And then I'm going to convert that to a simplified fraction. 2 out of 39. So this is equivalent to the simplified fraction. 2 out of 39, which is approximately, if I'm rounding, 0.0513 to 4.0513, rounding to 4 digits. So, you know, you got choices. It increased a little bit, which is interesting. But I do have 1 less M&M in the bag when I'm doing my second selection. So this probability would increase of it happening because I still have the same number of reds and browns, but I'm decreasing the total number of M&Ms here. So if you think about it, this total probability would be, just looking at situation 1 for itself, would be greater than this because as a denominator decreases, the total fraction increases, right? As a denominator, let me show you 1/3 and then 1/4, right? 1/3 compared to 1/4. As a denominator increases, right, the total fraction decreases. And vice versa, as the denominator decreases, the total fraction increases if the numerator stays the same. So I would expect this to be larger than this because the numerators are the same, but this denominator decreased. So this should be a little bigger. So it makes sense that this is a little bit greater than this, if that makes sense. Okay. Questions yet? This is good practice because this is the combination of the multiplication rule and the addition rule. M&Ms make you hungry? I don't know. I guess I don't like yellow anyway. Okay, there's one other thing that I want to calculate, the no yellow. Maybe I'll do the double too, but the no yellow. And again, I'm selecting 2, so with replacement, without replacement. I'm only selecting 2 M&Ms still. So I still am only multiplying 2 things. So, but now I want no yellow. Okay, so wait, how many are not yellow? So 6 are yellow out of a total 40. I don't want yellow. How many non-yellows do I have?
$34.
34. If there's a total 40 M&Ms, 6 of them are yellow, 34 of them are not yellow. So the probability of me not getting yellow on the first selection would be what? $36 non-yellows out of 40 total. I replaced it, so what's the second one?
That would be
36
36 over 40.
40.
You guys can also, yeah. You can also write it as this. These are independent events, right? Because the probability of the first, or the event of the first one happening, is not affecting the second one. I couldn't do it like this, 36 out of 40. I could do it like this, to the second power, 0.81, or convert it to a simplified fraction, 81 over 100. 81 over 100. This is very large. This is a large probability, a large percentage. Would you say it's highly likely that I go to this bag and I select 2 M&Ms and I don't get a yellow? Does it make sense, though, that that would be so large? Yeah, you know why it makes sense? Because only 6 of them are yellow out of 40 total. So I would say it's likely that I go and I pick 2 out of this bag and I get non-yellow, non-yellow. It doesn't matter what the other color is. It's just not yellow. Could be blue, could be red, could be whatever else I have here. Orange. Are there orange M&Ms? I don't even remember. But what happens if I'm not replacing it? The first one is 36 out of 40. What's the second one?
36 out of 39.
Well, yes and no. I do have 39 on the bottom, but I did eat the non-yellow.
35.
35.
Because you're not putting it back.
I ate the non-yellow because I like non-yellow, let's say, right? So, yeah. And then whatever that is, okay? Does that make sense? So far, so good. I only have one more here that I'm going to talk about, doubles. Just getting doubles. But see, here's the thing about this. You got a few situations here. First one could be, let's say a red and then a red. Or the second could be a green and then a green. Or the third one, I don't remember what colors I have here. Blue could be a blue and then a blue. Or the fourth, brown, orange, and red. A brown and a brown, probability of a brown and a brown. And then, what did I say? Orange and something. Orange and, I already did, oh, I forgot yellow. Oops. Orange and then an orange, and then yellow. Do I have everyone? 5, 6 ways that I can get doubles. Let's check it. Let's go here and just check it too, right? Are they part of this? So yellow, there's one of those. Green, blue, brown, orange, red. There's 6 total doubles. But I'm not calculating it, period. I'm doing it theoretically. Now this, a little more of a pain because you have 6 situations, but not a huge deal. All right, let's color coordinate this. Let's do red. I think we already did red. We did red. With and without replacement. I gotta do without replacement too. Without replacement is gonna be more of a pain in the butt, but all right, so red, how many reds did I have? 5. So we already talked about this, 5 out of 40, and I'm just gonna say to the second power, right? Because I'm replacing the red. I'm not changing the fraction because I'm selecting the same color twice and I'm replacing it. So if I'm doing the replacement situation, these are going to be the same. Does that make sense? Green and green. How many green? What's the probability of selecting a green? I guess that's easy because I have the same number of green as I do red. 5 out of 40. Squared because I'm replacing it. What's the next one? What did I say the next one was? Blue and blue.
8 blue.
8 blue out of 40 total. And then I'm replacing it, so I just have that twice. Okay, what was the next one? Brown. How many browns?
8.
8 browns. I'm trying to color coordinate too. 8 browns. Put it down here. 8 out of 40. Squared.
Orange is next.
Orange. Where's orange? Orange, how many oranges? 8 again. I don't know why I have so many of the same numbers. And then yellow, yellow.
6 out of 40.
Squared. All right, so a couple ways you can do this. I might have to change this one. It's not pink, it's yellow, but you can't see it, so I'm gonna make it pink. You could do it separately, where you do each one of them and add them together. Or I think we could just go straight and do it all in one shot. So 5 out of 40.
Handy dandy calculator.
Oh yeah, I love this calculator. 5 out of 40 squared plus 5 out of 40. Oh, all right, I'm not gonna go crazy. I could do 2 times that because there's 2 of them, but I'll just go straight. 5 out of 40 squared. I think the next one was 8 out of 40 plus 8 out of 40 squared. Wait till we get to without replacement. That's gonna be a good time. 8, 8, and 6. 8, okay, 8 and 6. 8 out of 40 squared. Do I have another 8? I forgot how many 8s. Yeah, I did have another one. Plus 8 out of 40 squared plus 6 out of 40. I'm having a great time. Squared. You might need to backtrack just to make sure. I have a 6, an 8, just to make sure you put it all in if you're doing it all like this, right? 2 5s, 3 8s, yeah, okay. And then if I want that in simplified fraction form, 139 out of 800. This is an equal sign. 139. I don't like that. That's ugly. So I'm going to go put that 0.1738. 1738. So there's a 17.38% chance of me getting doubles when I go and I randomly choose 2 from this bag. Now this is obviously, this is theoretical, right? This is if I continue to do this experiment over and over and over and over and over again. Now, I might not finish this one. Okay, well, we'll see. First situation, getting a red and a red, but now without replacement. When we did that already, this one I can't get away. I have to actually write out the 2. Look at this. I have to write it out because now
So,
I have dependent.
I have a question.
Go ahead.
So without replacement, because they're their own situation, each one of them would be, say, like green would be 5 out of 40, and then 5 over 39,
Well,
and then the
wait,
blue
wait,
would be
wait,
840, and then 839.
It
Well,
would be subtract 1 on both because you're not replacing.
Right.
so subtract the numerator too because you're eating the first one. So, you know, like if I'm doing red and red, I ate the red. So I'm not going to have 5 red
Right.
in selection. So the numerator is decreasing this time because of the fact that I'm selecting the same color twice
Right.
and I'm replacing. Whereas like some of these, you know, like the numerator stayed the same amount as the total because like this one was, you know, like this one was a red and then a green. So the numerator stayed the same because I had 5 red and I have 5 green. Me eating a red is not going to affect the amount of green. It's just going to affect the total.
Right.
But if I'm doing a red and a red, it's going to affect the total amount of reds and it's going to affect the total amount of M&Ms. So yeah, with each one of these, that's why I might not write all of them. Each one is gonna, and then I'm just gonna say dot, 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 but you get the drift, right? And then you have to go and add all those up, which is not so bad, but I mean, you know. But that's, then you're gonna talk about like, then you're gonna compare and talk about it and maybe, you know, think about why. And so that's your extra credit assignment. I think it's worth 10 points. Not 10 percentage points, 10 points, okay? And that is the gist of it. So, eat all of your extra credit assignment. I have questions before I'm gonna end the recording real quick. Let me end it before I stop, just to make sure that